Well, hello there. Thanks for coming to class today in the cosmos. I'm glad that you could join me. I regret that we couldn't be together, but sometimes the university makes me do things even though I have a class, and I apologize for that. But today we're going to start doing something which I think is really fun. We're going to start playing around with sounds. Matlab has a lot of great functions for creating sounds on your computer. Okay, so you can just create a sound using a tone in your computer. Okay, and so I want to show you how that works, and I want you guys to take these functions, start playing around with them, and then in class on Monday, we're going to start talking about sound and we're going to do some examples together. Okay, so, but let's look at some of the programs from today on the website. All right, so let me share my screen with you. Here we go. All right, I've got my MATLAB open, and let me close this. And let's go to the sound lecture here. Okay, so right now the first thing you want to download is this file, soundlecture.m. Okay, and actually let's start with a review of some code, because one of the things that somebody asked me a question about was the primes program. Okay, so in your primes program, one of the things you're going to need to do is you're going to need to make an array of all the prime numbers. Okay, and I just wanted to review a little piece of code here. Okay, and this is really simple. I'm going to call this array 7. Okay, and so take a look at this code here. All right, the first thing I did is I initialized an array. So this was initialize an array. Okay, and I want to create an array that's going to be filled up with all the even numbers up to a certain value. Okay, and I'm going to use a for loop to do that. Okay, so I've got my for loop here. Let me make this a little bit bigger. There we go. That's some nice code there. Oh, all right. So I've got my for loop here, and let's go ahead and create our for loop. I'm going to add my comments so you know what I'm doing. Okay, so I'm going to initialize an array. This is just going to be an empty array, and I'm going to use these brackets here, the square brackets. We're not going to use cells. We talked about cells last time. Cells are really exciting if you want to save lots of different kinds of data. But I'm going to make an array here, an empty array, and I'm going to fill it with numbers from my for loop. Okay, there's a couple of different ways that you can do this. And the easiest would be in my for loop. This is my for loop, and I'm going to say for loop where I is odd numbers. Okay, so I is odd numbers, because I said start at 1 and then go every second index, so skip a number and go up to 101. That's what these colons are here. If I take out the 2, remember that if I just have a colon here, this will give me every number in my array. Okay, and that's not what I want. We can try this just to see here what it does, because I always like to, when I'm programming, remember, I always like to run my code just as I'm going along. In fact, I usually run my code after I write like 1 or 2 lines because I want to see what it does. I want to always be looking at what my code does, and so that I understand what each line of code is doing. Okay. And this line, I'm gonna say grows array by concatenating value at the end. Okay. So I'm gonna basically add a value on the end of this and concatenating. There we go. Well, concatenating. So concatenating a value at the end. I'm gonna add on a value at the end there, blork. Okay. And I'm gonna run this and let's see what this gives me. Okay, so I'm gonna call this is gonna be array 7. Remember, I'm just pressing up on my keyboard. All right, and then I'm gonna press enter because I see a lot of people, they press up and then they go over here with the mouse. You don't need to do that. Okay, learn the hotkeys. Don't use the mouse for things. That's just bad. I mean, you can, but don't use the mouse. Okay, and I'm gonna run this. And whenever I run my code, okay, I also see a lot of people pressing run here. You can do that, okay, but I don't like to do that. I like to run everything from the command line because if I press run here, if this is the function, it's not going to operate correctly because I didn't give it any inputs. Okay, so I'm not going to do that. I'm just going to actually put the name of my file in. I'm going to call it array, and I'm going to move this tab over. I have too many tabs open. I'm going to call it right from the command line because that's how I like to do it. Because I always like to know what my inputs are going to be for that. Okay. And over here, I've got my array blork so we can see what the values of this are going to be. But you know what? To save room, I'm gonna make this a column array. I don't want a row. I want to actually see it over here on my in my value here. Okay, so over here I want to see what's in my array, and so I'm going to make a column. Okay, so I'm going to call array 7, and I'm going to go here and I'm going to hit Command S. There's a command where you don't have to go over here and push save with the mouse. Don't do that. That takes way too long. Okay, learn the hotkeys if you use a PC or Mac. All right, I'm going to run array. Boom. Okay, so this filled up with every even number because I just put I in there. Okay, I don't want to do that. Okay, now if I don't use this notation, so let's say I don't use my square brackets here, okay, because I want to make sure that you understand what I'm doing here, right? I'm gonna say blork, okay, and I'm gonna put a pause here. Oh no, we're gonna have that there. Okay, so just for testing, I'm gonna put a pause. I'm gonna say 1 second. Okay, I think that works. Number of seconds. All right, so we're gonna just see what this does, and this is gonna take too long. So I'm gonna say 0.5 there. I'm gonna hit Command S. I'm not gonna go over here and save it. I don't want to do that. And then I'm gonna go here, press up, and then enter. Okay, and so what is it doing? Well, it doesn't look like it's doing a lot. This is gonna take a really long time. I don't like this, so I'm gonna hit Command C. It's really taking too long. All right, I need this to go quicker. Let's say pause 1. Okay, and you know what? I'm not gonna put this in my array. Okay, and now I'm gonna say Control S, and I'm gonna go here. I'm gonna run my array again. There we go. So since I didn't make it into an array, okay, it's gonna go up to 101, and it's gonna be a single scalar value. That's not what you want. Remember, you're trying to create an array of numbers here, and the final value is blork. It's 101. That's the final value of my loop there. Okay, so I'm gonna make an array. I'm gonna put this in square brackets. I'll put blork here, and that basically takes what was in the array previously and adds a value onto the end there. Okay, and so let's run my array here. I'll say array 7. Okay, so my array is getting bigger now. It's printing this array over and over. That's fine. It's not going to put it in the memory until the program ends, and then over there on the end. Oh, but see, I made I made a row. I don't want a row. Okay, that's not what I want. I want a column. So I'm going to put a semicolon here. When I add this semicolon right there, that creates a column array, which is what I want. Because remember, whether you want a row or a column, that's really important to me. I can't emphasize how important that is, especially if you're taking a lot of data. Just trust me, it is. I'm going to hit Command S, save it, go down to my command line, and then I'm going to run this. Okay, now my column array is getting bigger. There we go. It's putting all my numbers in the screen here, and I just made it go slow because I wanted to see what its output is. Okay, because I like to, when I run my code, right, I want to see what's happening in real time. What values are going on there. I want to understand what my program is doing. All right. Now, that's every number. I want to make odd numbers in there. Okay? So, here instead of I, okay? Now what I'm going to do is I know the formula for odd numbers. I'm going to say 2 times I plus 1. Okay, this is the value for odd numbers. Okay, and but I'm just gonna give a little. I'm gonna drop a little clue here. When I'm making my array, it's not going to start at 1. All right. I could do that. I could say if I set this equal to 0, then in my formula here, the first value of I is going to be 0. That's going to give me a 1. It's going to fill up my array with odd numbers. All right. So now I'm going to save this, Command S, and then I'm going to press up and enter. Okay. Now I'm getting every odd number in my array, and that's great. Okay. So now I'm filling up this array full of odd numbers, right? And my program has finished, and now I've got an array of odd numbers all the way up to 203. Because if I put 101 here, then that equals 202 plus 1. That's 203. Okay, so that was my um that was my that was my array there. Okay, so now I've got every odd number. But the main thing I wanted to show you was this is how you grow your array, right? You need to use the square brackets, put your value in there, okay? And then, okay, and now we are going to, we've got an array of all of our odd numbers. Okay, so let's look at another something else we can do. Let's say I want to make a plot of this. Okay, but I don't want to just plot the odd numbers. Okay, because you can do that. It's fine. But let's make an array of all of our squares. Okay, this was actually on the test. So let's see if I can remember the formula for squares. Okay, so I'm gonna go from 0 to 10. Okay, because it'll start at 1, so 0 to 10. Okay, and now in my array here, I need a different formula. Okay, so what can I put? Well, yeah, I guess I can square all these numbers. Okay, so I'm gonna put squares here. Okay, so I'll say square this value. This is gonna give me all the squares up to 10 or whatever I say. So it's going to be my array of squares. Okay, and I'm going to plot it. Okay, and so now I'm going to make another array. I'll say x is equal to 1 to 11, 1 to 10. Okay, and there we go. So that's my array. Okay, and I'm going to make this equal to 1. Okay, and then down here, I don't want this to be, I want this to just be a row. I'm going to say plot X and blur. There we go. I'm going to make a plot of these numbers, my squares, and let's hit S. And so I'll call this one, we'll say this is X axis. x-axis for plotting. And this one plots all of my squares. There we go. All right, so let's save this. Command S. I'm going to go to the command line here. I'll just press up. Array 7. There it is. And did I get a plot? Let's see. Where did my plots go? Did it even make a plot? I don't think it made a plot. Why didn't it plot anything? Is the plot hidden? Where did it go? Well, all right. Okay, so my array has 10 values. And let's see what X is. What is X there? Okay. So it's an array, but why isn't it plotting? So I'm gonna just copy this line here. I don't know why I didn't plot. Should have plotted. I'm gonna say plot. Great question. Why isn't it plotting? Oh, I think I had a plot here. Let's close this one. Oh, oh, there it is. It was covered up. I remember that I had docked this. Okay, I'm gonna say first. I'm gonna say hold off. I don't want to save what was there before because this was from a different function. Now I'm gonna say plot blork. I'm gonna close this array. I want it to be gone. I'm gonna make a new one. Plot blork. There it is. There's my figure. Okay, but now in here, I want to see the numbers. I want it to be a red circle for my numbers. Okay, so I'm gonna say here, and now I'm gonna call my function again. I'm gonna say array 7, and there it is. Wow. Okay, look at that. No, where's my plot? Okay. All right, so there's all my squares. Okay, I made a plot of it. Okay, and I plotted my results. All right, so two important commands here. Okay, this is how to grow an array, and I'm also plotting an array. Okay, so this is I think pretty useful. Now let's go on to the sound. That was to help you for the test. Hopefully most of you have already finished it by now. Okay, let's go download this file called sound lecture. Okay. And the important thing here is we want to use this command sound. Okay, this is what's going to actually play a sound on the computer. Okay, and I've made a file here called sound1. Okay, and let's take a look at this. I'm going to hit clear here. Okay, and this program is going to play a note on your computer. And I took this from sound lecture here. Okay, I basically took this part. You can just copy and paste this from the first part of sound lecture. And let's go through and talk about what each thing is going to do here. Okay. And there's okay. So I think my program has some issues. I'm gonna fix those right now. Issues are good because when I have an issue, then that's an opportunity for me to explain it to you. Okay, so I want to plot this first. I want to create a sound wave. I'm going to comment out all this other stuff because the plot wasn't working, but we're going to figure it out together. Okay, and you can make this function yourself. The first thing that we're going to do is we're just going to play a note, and then later we can visualize that sound wave. Okay, so the first thing in the program here, clear. It clears all the variables. Okay, so when I execute clear, this go here. Clears memory so program can run correctly. Program can run correctly. All right. Then what I'm going to do is I'm going to ask the user, I'm going to say prompt, enter the frequency to play. Okay. And so the user can pick a sound to play. You can put whatever frequency you want in there. Okay. You need to specify f of s because this is important when you're using this command here called sound. Okay. And if you don't know what sound does, you can always go into the command line here and you can type in sound. And this is a great way. I always do this. I don't want to actually go look it up. Let's see what sound says here. Okay. So it play a vector as a sound. Okay. So you need to put a vector into this function called sound. Okay. And then it's going to play that note or whatever the tone is at a certain frequency. Okay. So sound Y plays the sound at the default sample rate. That's 8,192 hertz. Okay. That's, I think, how often your computer is going to make that noise. Okay. We can look that up. But here plays the sound using bits sample if possible. Most platforms support 8 or 16 bits. Okay. But the default here is 8,192 hertz. We're going to leave that alone. We can play around with it later if we want to. Okay, but in my program here, I'm going to say the user can ask what frequency they want. Okay, so it'll say, and I'm going to say input prompt. It'll say enter the frequency to play, and then note gets that number. So they're going to enter the number of the frequency. Okay, f of s, this is going to go into my sound function here. And then in sound, okay, so you need to specify a couple things here. Okay, you need to specify the time, okay, that you want to play the note. Okay, so when I say time, because remember we're putting a vector into sound. Okay, you can't just put a number into sound. You need to add a vector or an array. Okay, you need to have an array of values for it to play. And here, why? Because when you play this function sound, okay, then you need to specify at what voltage level you want the sound to play at. Okay, if you put a 1, that's sort of the maximum volume. We can change that. We can make it smaller. And I think Zoom will record this. I think it will. We'll try it. Okay. Okay, so frequency is my note. Okay, and here I'm going to say length. How long do I want this to play? Okay, so length is going to equal 4. And then delta t is going to be 1 over f of s. Okay, so my time here, that's how many steps I'm going to have up until length. All right, so if I say 8,192 or 1 divided by 8,192, those are very, very small increments. Okay, and so that means when I feed this into sound, I'm going to have lots and lots of data points for it to make the speaker play. Okay, so let's see what this function does. Okay, so I'm going to play sound 1. Go over here to the command line. And I will say sound 1. Okay, and it's going to say, what frequency do you want this to play at? I'll say 266. And what does it say? Error not using length, not enough input arguments. Okay, so I'm going to say length. Okay, so now I've got my time. I'll hit Command S. Then I'll say sound. There we go. And okay, so it played it for 4 seconds. Okay, and it played that sound. Now let's play around with f of s here because I want to see what this does. Let's put 100 here. I'm going to save this. I'll play sound 1 here and I'll do 266. That's the C. Invalid sample rate. No. Okay. So the sampling rate, this is something that is built into your computer. Okay. So you can't alter this too much. So we need to go back here and change that back. I'll say 8,192. If you look at the documentation for sound, there are fixed values that you can set sound. So let's go in here to the help function and we'll look at sound and we'll see what those values are because you need to specify specific values that are allowed on your system. Okay, so SoundWise sends audio signal to the speaker at a default sample rate of 8,192. Okay, so you don't need to change that. Okay, it says sample rate in hertz specified as a positive scalar. Valid values of sample rate depend on the audio hardware of your system. Typical sound rates supported by most setups are 8,100 or 11,000, 25, 22,000, 44,000. Oh, let's try 11,025. Oh no, I don't want that. Let's go back to sound. There we go. Delete that, and we'll try 11,000.002.5. I think that was right. Ah, that's better. All right, let's go up here. I'll say 266. So on my Mac, I can use 11,025. It's fine. It doesn't really matter. And it plays in notes on your computer. So if I put in a different value here, I'll say we'll try 100. That's a lower frequency. And so it's more of a bass sound. I don't know if you can hear it, okay, but play around with this on your computer. Try different frequencies. Okay, so that's 100. We could try something higher. I'll go 1,000. This will be very oh gosh, that was a terrible noise. All right. So that was a really just a horrific noise. So what I'm gonna do now is I'm gonna change my volume, okay, because that sound is horrible. Let's try something. Let's do a little experiment here. I'm going to say I want this to be quieter. That was too loud. I'm old, really old. That's too loud. So I'm gonna multiply my amplitude, because remember, this is Y here. This is the amplitude of my sound. So we'll say amplitude of my sound. Remember, you're creating a sound wave. In other programs like LabVIEW, you basically specify the amplitude of the voltage that you send to the speaker. Okay. And that voltage oscillates at whatever frequency you set. So 266 hertz, that's middle C. Okay. That's middle C. And so that's how quickly the voltage is oscillating in your speaker. Okay. The sampling rate, that's something that's hardware specific. And so that's built into your computer, so you can only use certain values. Okay. So let's see if this is quieter now. I'm gonna save this and then let's run it again, and hopefully this doesn't hurt my head. Like, okay, that didn't really. Let's try and make it really quiet. We'll go 0.1 there. I'll save that. Maybe this doesn't work. Okay. Okay, that does work. Wow. We can control the volume now. Let's make it really quiet. Okay, so I'm gonna say 0.01. Very quiet. Okay, I think it's a decibel scale. That's fine. So I'm gonna save it. And we'll go sound. We'll do 1,000. Ooh, very quiet. Okay, so if you want to control the volume, it's decibels, so you need to use logarithmic. Okay. So if you want it to be a tenth, so we'll go. Remember, you need to add a 0 here because we're moving logarithmic. Maybe you forgot what logarithms are. But that's okay. Remember, sound is in decibel, and so the power of the amplitude, or how loud it's going to be, is basically in decibels. Okay, so let's put 0.001. Now, I don't know if you can hear this in Zoom. I'm going to play it again later. I hope you can hear it. If you can't, write this code on your own, and oh, it works. It's very quiet. I can still hear it. I don't know. Okay. But okay, so we did it. Now, okay, so we've got our sound wave here. Okay, we've got a time vector and we've got a y vector. There's no reason that we can't just go ahead and plot the sucker. All right, so let's go ahead and plot it. I'm gonna say plot. Why not? We're gonna plot the sound wave. I wanna see the sound wave. Okay, let's plot the sound wave. Why not? Why not plot the sound wave? Let's see what happens. What is it going to look like? Well, you're probably not going to be able to see a lot, but And I'll show you why in a minute. So we're going to put in the x-axis here, time, and then y. Okay, so there we go. We've got delta t, 1 over f of s. Okay, so let's save this. Let's see if we get a plot. Then see if our plot even makes any sense. Put 1,000. And okay, so it's playing that for 4 seconds. Did we? Oh, okay, we did get a plot. Okay, but now, okay, we can't actually see the sound wave because I'll tell you why. Because there's so many data points, right? There's too many data points here. And look at our array here. Y, it has 44,000 data points. Okay, so that's a huge number of data points, and so we can't actually plot that. Okay, or we can plot it, but we can't really visualize what this means. We want to zoom in on a tiny little bit of frequency space here, and so we just need to look at just a few data points. Okay, so let's try something different here. Let's say time from, because time's an array, so I'm gonna go from 1 to 100 here. Okay, I've never actually tried to index an array and plot, but it makes sense. You should be able to, right? I mean, it just makes sense, right? Of course it does. You're like, Dr. Woodley, of course. You're so right. Thank you. Oh, okay. So we'll put in 1,000 there. Oh, I hear it barely. Barely I can hear it. I don't know if you can hear it. And then my plot. Oh, boom. There's our sound waves. Okay. So we're zooming in here on the sound waves. And this is over a very short time period here. Okay. And you know what? I want to change my plot here because I want to say let's make it blue. Let's say blue O's, or maybe triangles. Let's try triangles. Let's see. I want green triangles. Yes. Okay. And I'm gonna make my volume a little louder here. Let's put it back to 0.1. No, let's say 0.05. Okay, I'm gonna save it. I'm gonna run my program here. I'll say sound. I want 1,000. Okay, I hear it. That's pretty. It's kind of loud. Not too loud. Not to. Oh, green. Okay. Wow. Can't really see anything with green triangles because it's like too late. That's fine. Let's go back to our program here. Maybe red triangles or blue triangles. That should work. Okay. There we go. Blue triangles. And I want to connect those. So now I'm gonna say, that's some kind of emoji. What emoji is that? It's like a Cyclops frowny face. Yeah, my Cyclops frowny face. Wow, we just invented a new emoji. A Cyclops frowny face. Wow. You know what? It's Friday afternoon and I'm a little loopy. Okay, so there's 1,000. We got this, and oh, look at that. Beautiful. Yes, I'll put this in here. Okay. I like it. I like it. Now let's look at I'm gonna put hold on here. I'll say hold on, and I want to compare the frequency of this. Let's go to a different frequency this time, and I'll do red triangles pointing the other way. Yeah, they're pointing this way. So it should be, oh, look at this. It's a, what emoji is that? What's an R? And this looks like a smiley face with a nose. This must be a pirate smiley face. That's an emoji, right? Yeah, I think it's an emoji. Okay, so I'm gonna save that. And now since we put a hold on there, okay, I'm gonna say our frequency, we'll want, let's say 200. That's, or 266, that's middle C. Oh, look at that. Oh man. You know, as a physicist, I look at this plot and I say, oh, Dr. Wisby, that's amazing. Oh, what a great plot. That's some great data there. Oh, you know what we need is we need a legend. Okay, let's say legend. And we'll say the first one is 1,000 hertz. 1,000 hertz. Boom. And we'll say the next one is 200 hertz. I should have put that in the program, but hey, whatever. Because I could add that. So I'm gonna say legend. Boom. Wow, look at that. You can just type it into the command line there. What? I know you're like, that is so great. I know, right? It really is. And I want to, last thing I want to do, okay, and as a physicist, this is so important because I'm gonna, well, we'll close this and we'll recreate it in a minute. But I want to label my axis, okay, because I like to have the axis labeled. And what I'm gonna do is I'm gonna go back and look at one of my old programs because I remember that I had this one program where I labeled the axis. Okay. Oh no, wait, it's not this one. Where's my plot H? Okay, where's this one? Axis. Did I label the axis window? You know what? It's fine. Okay. That's fine. We're just gonna have to go to the help here because I don't remember what the commands are. I know I want to label the axis. So I'm just gonna open the help. Why not? Why not just open the help? Save yourself some time, man. If you don't remember, the best resource here is just go right in here to this window. Go to the help, type it in. It doesn't matter if you're online, if you're on your computer. Okay, we're gonna get some. I just want to know how to label the axes. I don't remember. You don't have to remember. It's fine. Okay. Oh, look at this. Here it is. Boom. Cosine of 5x. I just went. Oh, look at there it is. Oh, x. Of course. You can even label your plot, man. I'm just, you know what? I'm just gonna, and I'm even gonna copy that right out of there. I'm just gonna steal it. Command C, copy and paste. Okay. I found what I wanted. I'm gonna close my help file, and I'm gonna go over here to sound. That's the one that I was working in. Okay, and I'm gonna put these in here. So title. Okay, I'm gonna call this. My title is visualizing sound waves. Visualizing sound waves. Yes. Sound waves. Okay. That's fine. Okay. We're going to generate a plot here. My X label is going to be X. And then this one, oh no, it's not going to be X. It's going to be frequency. Frequency in hertz. Always put the units there. Put it in parentheses because that's how you do it in science, right? And then here, this is going to be amplitude. So sound wave amplitude. And I'm thinking about the amplitude that the speakers are oscillating. So amplitude, or we could call it volume. We'll call it volume. And I don't know what the decibels are, but we'll call it dB, okay, because it's decibels, but I don't remember what the code is, or I don't know how it translates into decibels. So that's another question. That's another class period. How do we find out what decibel it is? Okay. And then here in my legend, I'll just put that in my program because I don't want to have to type it into the command line. But that means when I execute the program, I'm going to have to say 1,000 hertz first and then 200 hertz. Okay. So let's execute our program here. Sound one. I want the first plot to be yeah, it'll be red triangles. It doesn't really matter. We'll say 1,000. Okay. Okay, so we've got a 1,000 there. And I only had one argument, so it kind of doesn't like that. That's fine. And you know what? I'm gonna take that out of there. We'll have to fix that later. I'll just comment out this legend here. Okay, for now, we'll put it back in later if we want to. I'll say sound waves and then 200. Okay, and it added it to it. And I'm gonna say hold on. Okay, and then I'll run my program again. Sound one. And I'm gonna dock this. I'll put it over here. Here's my sound waves because I really like to visualize things when I'm doing it. It's really important because you need to know what your program is doing. You need to know what's in the array and what it's going to plot. Okay, so I'll say 1000 here. Okay, and I put the second one. I didn't change the color, my program. So I'd say this program is a limited usefulness. Yes, fine. I could program these different sounds into my program, and that would probably make it easier if I know the tones that I want to play. Then I could just play those tones and plot those tones. Which, if you look at this program here, Sound Lecture, it actually does that. It plots all these things together, and then it uses subplots to display them. Okay, so first let's run our program here. Again, I'll do sound. I'll do 1000 first. Okay, there's my program or my plots. I'll put it down there. Okay, and I'll say hold on. Now I'll change this because I want the markers to be different. So I'll go back to B and I'll do triangles. Oh, what happened? Whoa, I don't know what happened there. Phased out just for a second. I'll do we'll do red. We'll do red circles. There we go. Blue circles. But triangles and circles, those are very different. So now I'm gonna run my program again. I'll say sound one, and we'll do 266 hertz. Okay, let's look at my program. All right, so I've got both of these. Okay, now I'll go back up here and I'll say I want to make a legend on my plot. I want to finish this plot. And so the first one was 1000, and now I'm gonna go back and I said 266. That's middle C, and I'll type that in, and now I've got a legend here in my plot, and you can actually like move it around, which is that's pretty convenient, man. Oh, okay. So I visualized both of my sound waves, and I made each of those tones, and I've got a really nice plot here. Okay, so this would be great. Matlab does a great job of plotting it. Okay, well, on Monday we're gonna go more in depth about sound and all the different things that Matlab can do for sound. So thanks for tuning in and watching my YouTube channel. I hope you click like and subscribe. That would be so great. But have a great weekend, and I will see you on Monday. Talk to you later.
Thank you. Like and subscribe down below.